Hello? Okay, just gonna make this brief video explaining what my project, my final project is and how it works. So yeah, let's get right into it. Okay, so basically, I made a audio spectrum analyzer, and to do that, we use a fast Fourier transform. As far as I know, that's the only way you can do that. Maybe there's a different way, but I don't know. If there is, it'd be interesting to learn about. So yeah, the audio library I used to make this work is called R Audio, and that basically lets me use functions out of that library to stream the audio from the hard drive, the audio file that's saved on my drive. It gets streamed to the audio hardware for playback, because there's no way I could implement all that stuff myself. That would be an entire project, entire separate project of its own. So yeah, there's raudio.h, raudio.c. So yeah, those are free and open and available to anyone. You can get them from their official website. It's actually used in a lot of indie and open source games and stuff. It's like a fairly popular library. R Audio, there it is. And to compile it, our audio has a few dependencies, and they're all in this external folder here. So these are all the dependencies. One interesting file in particular is miniaudio.h, which is used by a lot of stuff, I'm pretty sure. So our audio is already like a lot of audio backend, and actually our audio uses even more like separate audio backend, and most of it's found in this mini audio file, which by the way is like 95,000 lines of C code, which I thought was kind of interesting. It's actually kind of terrifying looking through it. I don't understand what's going on there. I don't know why that file is so big. But yeah, I guess audio processing backend is very complicated and extensive. So yeah, there's that. So I'll include that folder and our audio C, our audio H in my GitHub for this final project submission. And as long as you have those in the same folder as the source folder here, everything should just compile and run. I'm like 99% sure. Because you can see I'm including our audio.h there. So yeah, basically I include our audio in glview new module, and we declare a member of type music, and music is declared in our audio. So that's how we're using some of the features. So we have a music member in our object here, so we can call upon it and do stuff with it. So I'll show you how that works here. Okay, so yeah, basically I use I'mGUI to spawn a window with little widgets and buttons on it, and when you hit the play button, okay, yeah, so I'mGUI makes it spawn an audio controller window, and when you hit play, it launches DoThread. Let's go to DoThread. DoThread creates a couple threads actually. One of the threads it starts the audio streaming. which happens here, update music stream. It's in an infinite while loop. So that stream just kind of runs and continuously does that loop, and it updates the music stream like block by block. And what that means is it just pulls audio data off the .mp3 song you have on your hard drive somewhere. It takes blocks of that data, loads it into a buffer, and then that buffer gets pushed to the audio hardware for playback, and that's how you hear the music. Something weird that happened, for some reason it only works, at least I only got it to work, if I put the MP3 file in the very root of my Windows drive. So it couldn't find it anywhere else. I don't know what's up with that. I tried a lot of different locations. I like tried to put this MP3 file in different various locations and stuff, but this is the only spot I could figure out where it worked. Don't know what's up with that, but that's just how it works for now, I guess. I don't know what I was doing wrong, but that's the only way I could figure it out. So yeah, that's what Audio F does. And then so while that's streaming, we actually create another function spawned by a thread, or a function inside a spawned thread, I guess is a better way of describing that, called buff copy. That's the function that does a lot of the work, other than the fast Fourier transform function. The fast Fourier transform function gets called from buff copy. So what buff copy is, I don't know quite how this works. I've never used this before, but it's actually seems very interesting and handy. So there's this function here, attach audio stream processor, that's part of our audio, and so when you use it like this, it somehow kind of like lets buff copy share the same memory as this attach audio stream processor function. So buff copy, okay, so it has frames and a void pointer buffer, and those two parameters there, they're actually exactly the same as that. It's like twin function that's part of our audio. So whenever like that function's twin gets called in our audio, it does a bunch of audio processing, and whatever's happening to the audio buffer there, we have a pointer to it here. So whenever that function gets called, actually our like twin function buff copy here gets called too, so we can do work on the same audio buffer, which is pretty handy. So there's like a technical word for whatever that type of function is, but I forget what it is. It seems pretty useful though. So yeah, this pointer to buffer, that is the audio buffer that's getting played, so we're going to do stuff with it. So at this point I'm just going to show you how it works. Okay, yeah, so IMGUI makes a nice cool little window for us to use here. Okay, so if we do audio menu, when we hit the play button, just previously I was talking about how it spawns those threads that initialize the music stream. That's what's going to happen here. So hit play. Of course it does that. Okay, one of the shortcomings here is it's actually like it's very glitchy. It crashes a lot, and there's a lot of like weird little audio distortion that happens. Not sure what's up with that. I can never get it running like super smoothly, but it runs well enough to demonstrate that some of the stuff I did is working at least. Okay, so we can hit pause. So if we hit pause, it pauses the music stream. So basically what's happening in our function that does all the work, buff copy. So basically, we have a pointer to the buffer, and we take multiple of those buffers and glue them together in one long frame, because that frame is what we need to make like a nice, pretty audio spectrum graph. Otherwise, it's just like too short and boring to really get a lot out of it. So yeah, what this series of ifs is doing is basically kind of like measuring the size of the buffer in comparison to the frame we're putting the buffers in, and it kind of arranges the buffers around in that frame and glues them together in a nice way, so we get a nice long pretty frame for us to use. And I think we take like 7 of those buffers, something like that, and put them together in the frame. So that frame is like 7 of these buffers. Otherwise, we couldn't really do anything with the buffer data, because the buffer actually gets filled and dumped like several times a second. So that data is just gone like way too quickly. That's why we have to copy it. So yeah, and what we're seeing here is that those chunks of buffer, like 7 of them glued together into this frame, and this represents the undecomposed audio spectrum. So what we see here is all the different frequencies sandwiched together to make the music. That's why the signal looks kind of so like crazy. But yeah, here is the audio wave. That's what the music that you're hearing looks like, visualized. Okay, down here is the fast Fourier transform. Okay, so we're going to unpause it and let it play. Okay, so yeah, when we get more bass, the visualizer here will indicate that with these big, long, like swoopy waves, because the bass is much lower frequency. The waves are a lot longer. See, yeah, it just did there. Those big, tall waves, that's the bass. And then like the hats and snares and claps, that's a higher frequency, and that's what we're seeing here. And of course, it's being visualized down here. So, like the bass is on the left side, and those claps are kind of more towards the middle. You can see them. Alright, I think that's a snare, not a clap. But yeah, so higher frequencies are on the right side. Lower frequencies are on the left side. Okay, and I found sort of a way to demonstrate that the fast Fourier is actually working. So we're gonna add in our own frequency into the music. So we create a pointer called D here to the buffer, and then we're gonna add stuff into D. So whatever we do to D actually happens to the audio buffer that's getting played in real time. And basically we just do some trig to add in our own frequency here. It gets this shoot, I forget what this does. Well, okay, so basically, okay, yeah, audio frequency is controlled by this slider here. So whatever we set the slider to, it's gonna splice into the song. And then amplitude, of course. So frequency is just the frequency of the sound we're gonna add in, and then the amplitude is how loudly we can hear that frequency. So yeah, we're just gonna. Okay, I don't know if you can hear that. So yeah, see, it just went higher. Then make it lower. Yeah, if you slide it back and forth, it makes that cool sound. It's like very, it's kind of like a whirling noise. Okay, and then if you see that down there, that is actually this frequency we're adding in. See, it goes to the right, and it goes to the left. It's kind of subtle. You have to know what you're looking for. If I increase the amplitude, it gets taller. See, it's gonna go to the right, and then the left. See, around right there, that peak is that frequency we're adding in. So like if I'll make it go left, and then back right. It's kind of hard to see. You have to see what you're looking for. But yeah, hopefully you can see what I'm talking about there. Very small down to the ground there. Yeah, so yeah, there's that. That's pretty cool. There, you can really see it right now. If I go right, it goes to the right. If I go left, it goes to the left. Right, left, right, left. It's very small bounce, like hovering around there. So yeah, that's how that works. And then a bit about the FFT. Yeah, basically, we take that frame that's made out of like several smaller buffers, and we pass it into our FFT function. And we select a bin K, and then it performs the FFT. So this is the FFT. Over the summer when I was working on this, I actually visualized what this was doing pretty well, and I don't remember it anymore. Like I can't really see what it's doing anymore. It's like a lot of math. But yeah, one thing that I'm very confused about is the bin K. We select it up here to be 512. So if my understanding of how this works is correct, whatever your bin K is, half of it will be the like highest frequency you can detect. So if I understand how this works correctly, so theoretically we should only be able to detect like 256 hertz, which is very, very low bass. But on the visualizer, you could see it kind of, you could really see how it was finding the higher frequencies too. Like it showed a lot of bass, but you could also see like some of the piano keys, and like especially the snares and the claps. Those are much higher frequency. I'm like pretty sure they should be well above 256 hertz. So like treble range. So I guess my understanding of how the theory of this works must be like incorrect, because best I understood, it shouldn't be able to find those. So what it's doing, I don't know, but it looks pretty pretty obvious that it works. Yes. So yeah. Like I said, not sure how it's doing that, but yeah. And of course, there's like a bunch of like overhead for the audio to like set up, you know, the parameters of how you want your audio to be streamed and stuff. That's what all this stuff is. Yeah, I'm not sure how much more stuff there is to explain here. I mean, that's a pretty good summary of what's happening without going to too much depth. Here's the I'm GUI code to actually display the graphs of what we were seeing there. Yeah, so I mean, that's pretty much it, I'm pretty sure. And then, like I said, I didn't have to touch the CMake files at all for this, I'm pretty sure. So it should just compile in with like standard Afterburner setup. All I did was just have that external folder included in the same folder that you're compiling from, and all I did was just include our audio.h. So yeah, it should compile, I hope. Yeah, other than that, that's pretty much it.